Hi everybody, this is part 3 and it'll be the final part of my first stage of videos on using the light dependent resistor here to control the brightness and watt consumption of a joule thief. I did a big torture test last night before I went to bed. I set it with all the lights and everything turned out. We were using 4.6172 watts when I went to bed. That was at 1.190 volts and 3.88 milliamps. Didn't work quite as well as I'd hoped. I was hoping it'd be about the same when I got up in the morning. 8 hours later, we had 3.4335 watts using 1.091 volts at 3.150 milliamps. But it's better. I think it's better than what I would have got had I not been using their LDR. And that's one of the mistakes I made. I'm going to need to make 2 identical joule thief circuits, one with the LDR and one without, to compare the two. And as you all know, it takes a while to wind up these toroids, and I'm going to need to make 2 identical ones. So there could be a bit of a wait before we get too much more videos coming up on this topic. But any of you that are playing with this at home, you've got something to just get you started now, so that should help. Just so you can see, I've got volts on today. The battery's showing a bit over 1 volt. That's connected directly to the battery via these white jumpers. I've got my current coming out of the positive going through this multimeter. We've got the scope there. I'll rattle off some figures off my scope here, although I should note that this scope isn't calibrated. I do need to get my hands on a very good laboratory grade power supply to calibrate it. It's pretty close though. What's the big giveaway? It's flickering here right now. I'll bring it up close where hopefully you can see. And hopefully, there we go, the camera's focusing on that. So out of this yellow block here, we're showing 9.2 volts. Yeah, this multimeter's clearly telling me it's a bit over a volt, so we know there's a bit of a discrepancy there. RMS voltage is 1.8ish at the moment. Max peak volt is 3.2 volts, that's that peak there. Minimum volts, that's the bottom line, we're running right on 0, right where it wants to be. That is cycle time, so that is the time from the rise of the peak to the fall of the second peak. It is 2.9 microseconds. The frequency we're running at the moment is 340.7 Hertz. That's giving us a duty cycle of 26%. The voltage peak to peak is 3.2 volts, which is exactly what we want to run an LED. And then I've got voltage DC at the bottom again. Let's just scroll down there. Yeah, there we go, and see what else we can see. RMS, we did that. Max, min, frequencies, duty. I think that's all we can do. Peak to peak, yep, that's it. Changing colours is just going to different channels that aren't plugged in, that's totally pointless. Anyway, so it is working a bit, I think. I think it did help keep things running in the sweet spot overnight. The light output was certainly very consistent. Although that was another mistake I made. I forgot to measure things with my lux meter before I went to bed. But anyway, it's a start. Making mistakes is how we learn. So, thanks for watching again. Good luck to anyone that wants to try this at home. And if you have any questions, comments, feedback, please feel free to comment below. Thank you for watching.